Right, children. Now we are going to start the next chapter of the lesson. Now, do you remember what we learned in the previous chapters? We learned how to generate heat energy, and at the same time, we learned what are the effects of heat. So, do you remember what we learned under the effects of heat, children? We learned about increase of temperature. So, under that, we explained that when heat is provided, the temperature of the objects increase. Okay? And secondly, we discussed about expansion. So, under that, we discussed that expansion of solids take place when heat is provided, right? So, under expansion of solids, we learned that when heat is supplied, what happens to the solids, children? The solid size increases. Now, this chapter, we are going to start with expansion of liquids, okay? So, our activity is, let's learn about the expansion of liquids, okay? Right. So, what are the materials we need? We need an empty bottle, and we need a rubber stopper, and we need an empty pen tube, and we need hot water beaker and some ink. Okay? We'll write glass bottle, rubber cork or rubber stopper, empty pen tube, and we need a hot water beaker or hot water basin as well. And finally, we need some ink. Okay? Glass bottle, rubber stopper, empty pen tube, hot water beaker and ink. Okay? Let's see how to do this activity. Right. Look at the setup. Let's label this first. This is the empty pen tube, colored water, hot water. This is the empty pen tube. This is colored water. We use ink. Colored water and hot water. We label the bottle and the beaker as well. So this is the bottle and this is the beaker. Okay, children? Right. How to do the activity? Take a rubber cork, and rubber cork means the rubber stopper. Right? Take a rubber cork and make a hole in the middle. And put the tube of the pen through the hole. You all can see. We couldn't mark the rubber stopper. We'll mark that as well. This is the rubber stopper. Or rubber cork. Right. Right, put the tube of the pen through the hole and put ink into the bottle with water. So this is a water bottle. You have to add a few drops of ink so that the water will get colored, okay? Fix the cork to the bottle and place the bottle in hot water beaker, right? So when you fix this rubber cork with the empty pen tube to this bottle with colored water, you will see that the colored water rises through this empty pen tube up to a certain level, right? So we have to mark the level, right? Then what you have to do is you have to immerse this entire setup, which means with the bottle and the pen tube with colored water, you have to immerse the whole setup in hot water. And you have to observe what happens to the level of this colored ink inside the empty pen tube. Okay, children. So you are going to see when you immerse this bottle in hot water, this level rises up through the empty pen tube. Okay, children. This happens when we immerse this entire setup, this bottle in the hot water. Okay. Now, to understand this better, we are going to do the same activity with different types of liquids. Okay. Here, for further study, this setup can be used to observe the expansion of different types of liquids. Right? You can use bottles that are similar to the bottle to which a pen tube is fixed. Put equal amounts of coconut oil, kerosene oil and alcohol to bottles and keep them in hot water for the same time. Then what we are going to do, you will understand this better when we do this activity. So you have to use similar vessels for coconut oil, kerosene oil and alcohol. There I am going to use test tubes of similar size. Okay, we'll draw it. Test tubes. Right. You can draw it like this. And to one test tube, we have to put coconut oil. To the next one, we can put kerosene. To the third one, we can put alcohol. There I am going to use colored alcohol. That is because alcohol is a colorless liquid. So to observe it better, when it moves through the empty pen tube, to observe it better, we can use colored alcohol. Even here we used colored water because water is colorless. We cannot see how this level of water moves through the empty pen tube when we immerse it in hot water bath, right? Therefore, we can add some color and we can use colored water so that we can observe it clearly, right? Okay. So the same type of setup. This one alcohol, colored. Right? And in the same way, we have to take 3 similar rubber corks and fix 3 similar empty pen tubes, and you have to fix this to this setup, right? We'll draw that as well. Empty pen tubes with cork. You have to fix it with rubber corks like this. Rubber stoppers. So what will happen? Coconut oil, kerosene oil, alcohol in the same levels, same amounts, and the same types of 3 empty pen tubes should be fixed to these 3 test tubes, right? So you will realize that if you fix it properly, they all will in the same level, at the same level. Okay. Now you have to immerse these 3 test tubes with 3 different liquids in the same water beaker, hot water beaker. Right? You have to immerse these coconut oil, kerosene oil and alcohol containing test tubes in the same hot water beaker, and you have to observe what happens. Right, children? Okay. We'll do these 2 activities in the lab now. Right, children? Now we are going to study the expansion of liquids. Earlier we studied the expansion of solids. Now we all know that when we supply heat to a solid substance, its size increases. So we are going to do the same type of activity here, but this time we are going to supply heat to a liquid, okay? So look at this one, children. This is a test tube. Now this has colored water. So what is the reason of using colored water to do this activity, children? That is because water is normally colorless, but when we use colored water, we can observe the changes very clearly. Now you all can see this is the test tube with colored water. this is a rubber stopper. We have fixed this empty pen tube to the rubber stopper. You all can see very clearly, right? So the water level inside the rubber stopper also you can see if you observe carefully. This is the water level. You can see very clearly. Okay. Now what I'm going to do is I'm going to immerse this test tube with this empty pen tube and the rubber stopper in a hot water beaker. Now here I have a hot water beaker. Now when I immerse this one, you have to carefully observe what happens to the level of this colored water inside the empty pen tube. Okay. So using the test tube holder, I'm going to hold it like this and I'm going to immerse. Now see, now this time this is where the level of the water is. You have to check what happens to the level when I immerse this in this hot water beaker. Right, you all can see the level increases. The level of water increases. Right. So the level of water gradually increases when we immerse this test tube in the hot water beaker. Right. So it's very clear because of the heat, the level of water increases. So what is the reason for these children? Now earlier, the level of water was up to somewhere here, right? So when we provide heat to this water, what happens, children? The water expands, the volume of the water increases. Okay, children, the volume of this liquid or this water increases. So when the volume increases, it doesn't have anywhere else to go other than going up through the empty pen tube. Okay, children, that is why, because of the increase of the volume, we can see that the water level rises up. Okay, children. So it's very clear when we provide heat, what happens to the liquids, children? Its volume increases. So earlier we discussed that when we provide heat, the size of the solids increases. And here we can, it's very clear that when we provide heat, the volume of the liquids also increases. Okay? Right. So after doing this activity, it's very clear that when we provide heat, the volume of the liquids increase. So this is known as the expansion of liquids. Do all the liquids expand in the same way? To test this, we are going to do another small activity. Look at these 3 tubes, children. There are 3 different types of liquids in these 3 tubes. So in the first tube, we have coconut oil. In the second tube, we have kerosene oil. In the third tube, we have colored alcohol. So alcohol is a colorless solution. To observe the changes clearly, here we are going to use colored alcohol. Okay. So you all can see, like the previous tube we used with water, colored water. I have put these 3 liquids to 3 test tubes, and in the same way we have connected empty pen tubes using rubber stoppers. Okay, children. So you all can see the level of liquids inside the 3 empty pen tubes are almost equal. So we are going to do the same activity like before. I am going to immerse these 3 test tubes with 3 different types of liquids in this hot water. Right. Observe carefully what happens to the levels of liquids inside the pen tubes. You all can see the levels are increasing. So the tube with alcohol, the level increases. Here we have the colored alcohol. And the second one, you can see the kerosene oil, the middle one. Right. Coconut oil layer is also rising, but slower than the other 2. You all can see. Right. Okay. Right, children. So we immerse these 3 different types of liquids in hot water. at the same time and we kept it for the same period of time. But you could understand that during the activity, this colored alcohol solution, it gets heated up fast and it expands faster. That is why its volume increases faster than the other two. Right? So after doing this activity, it's very clear that when we provide heat, the liquids expand, it increases the volume and they expand. And when we take different types of liquids, they expand in different levels. So I'll show you this first activity. So you saw what happened when we immerse this colored water in the hot water. What happened, children? It increases. The level increases, but now you can see it has gone down again. Right? Earlier, after immersing it in hot water, it was somewhere here, but now the level has gone down. Why does this happen, children? When we heat a liquid, it expands, therefore the volume increases. When the heated liquid cools down again, what happens, children? The level decreases, which means the volume reduces. And this is known as contraction. Right, children? So you observed what happened in the activity. Right, children? So you all remember, instead of this glass bottle, I used a similar test tube like this. Right? I used a similar test tube with colored water and I immersed it in a hot water beaker. What happened to the level of the colored water inside the pen tube, children? It rises, it increases. The level goes up. Why does that happen, children? You all know that even during the activity I explained y'all what happens when we immerse this bottle, or there in the activity I used a test tube. Right, the test tube with the colored water, what happens, children? When we immerse it in hot water, that colored water absorbs heat. When the liquids absorb heat, what happens? Just as solids, they expand. Right? So in a liquid, what happens? The volume increases. Understand? So when the volume increases, what happens? It needs more space. So earlier, up to this level, it occupied the space inside the bottle and inside the empty pen tube. But because of the increased amount of volume, what happens? This water level rises. Okay, children, which means when we supply heat, the liquids expand. Expansion of liquids means because of heat, the volume of the liquids increases. Understand, children? Right. Now, do you remember the second activity we did? We did the same activity with 3 different types of liquids. There we filled 3 test tubes with coconut oil, kerosene and alcohol, equal volumes, and then we immersed these 3 test tubes in the same water beaker, right? The hot water beaker. Right, children? There what happened, children? Again, because of expansion. Now, these 3 liquids, they absorb heat and they expand, which means the volume increases. Right? So, when the volume increases, what happens? These levels go up inside the empty pen tubes. The liquid levels go up. But did they go up in the same way, children? No. Right, children? So, I think you clearly remember these 3 liquids increase the volume in 3 different ways at 3 different levels. Okay, children? So, the liquid that expands more increases the level faster than the other liquids. Understand, children? So, after doing this first activity, it is very clear because of heat, liquids expand, which means the volume increases. What can you decide after doing the second activity? What is the conclusion of this activity, children? After this activity, it's very clear different types of liquids expand in different amounts at different levels. Okay, children? We'll write the observations and conclusion. Observation. I'm going to first name this one activity 1 and this one activity 2. Right? Let's write. Number 1. The level of colored water in the empty pen tube. empty pen tube rises or increases, goes up, right? Second activity, the levels of different liquids, the levels of different liquids go up in different amounts. In different amounts. Okay. So the first one, the level of colored water in the empty pen tube increases. Empty pen tube increases. The level of colored water in the empty pen tube increases or goes up. The level of different liquids go up in different amounts. In the second activity, when we used coconut oil, kerosene and colored alcohol. Okay? Right. We'll write next. Conclusion. So according to the first observation, what is the conclusion? So we can conclude that the liquids expand because of heat, okay? When heat is applied, liquids expand. So what happens there? The volume increases. Volume increases. So what is the conclusion for the second activity, children? Expansion of different liquids take place in different amounts, right? Expansion of different liquids takes place in different amounts. Okay. So the first observation, the level of colored water in the empty pen tube increases, right? So what is the conclusion according to that? When heat is applied, liquids expands, right? So which means the volume increases, right? Number 2, the levels of different liquids go up in different amounts, right? What is the reason? So what is the conclusion for that? Expansion of different liquids take place in different amounts. Understand, children? We'll move on to the next. Right. Look at this one. What is this, children? We already used this instrument. This is the thermometer, right? Thermometer consists of alcohol or mercury, right? Most of the time, there are different types of thermometers. Now, this is known as the bulb thermometer, right? So, these type of bulb thermometers, a liquid is filled inside the bulb. So, basically, to fill this bulb, 2 types of liquids are used. That is mercury and alcohol. Mercury is a liquid metal and it is silver in color. Right, children? And when it comes to alcohol, I told y'all, alcohol is a colorless liquid. So if we fill this bulb with alcohol, what will happen? You cannot see how it moves through this thermometer. Therefore, here we use colored alcohol. Right? Look at this one. This is a red color bulb. This is filled with colored alcohol. Right, children? Because mercury is silver in color. So when it comes to this thermometer, here the theory used is expansion of liquids. Right, children? So let's say that if we want to measure the temperature of hot water, what we have to do is we have to immerse this bulb of the thermometer in water. Right, children? So you can see that when we immerse the bulb of the thermometer, what happens? This level inside this tiny tube, and this tube is known as capillary tube. Right? The liquid level inside the tube rises. What actually happens when we immerse this bulb in the hot water or any other liquid? According to the temperature of the liquid, that heat is absorbed by the bulb, and inside the bulb another liquid is present, either mercury or alcohol. Right? So because alcohol or mercury absorbs this heat, this liquid inside the bulb expands. Because of the expansion of liquids, which means the volume increases, that increased volumes go up. Okay, children? So accordingly, according to the temperature of the water beaker, the liquid level inside the capillary tube goes up, and thereby we can read what the correct temperature is. Right, children? So thermometer consists of alcohol or mercury. Right? Alcohol or mercury. It should be colored alcohol, right? What happens to the liquid when the temperature increases? When the temperature increases, the liquid level increases inside the capillary tube, right? We can explain using the expansion of liquids. Now, I already explained y'all what actually happens when we immerse this type of thermometer in hot water beaker, right? So the liquid inside the bulb expands and it goes up through the capillary tube. Now we are going to see different types of thermometers that we use in our day-to-day activities. Right, children? Now I'm going to show you some different types of thermometers. Now we all know that we can use thermometers to measure temperatures. Now when it comes to thermometers, there are two main types, bulb thermometers and digital thermometers. Now look at the first thermometer, children. This is a bulb thermometer. Look at this one. It's made of glass. This is the bulb. What is the color of the bulb, children? It is red in color. Now earlier I explained y'all that we can use two different types of liquids to fill the bulb of the bulb thermometer. That is mercury and colored alcohol. Now here this bulb is filled with colored alcohol. So why do we use colored alcohol, children? Because normal alcohol is a colorless liquid. We can't read the thermometer temperature easily with a colorless liquid. So to observe clearly, we use colored alcohol, right? So look at this one. This is the bulb, right? So can you all see a small tube-like part that goes through this thermometer that is known as the capillary tube, right? So according to the temperature, when we immerse this bulb in a liquid, according to the temperature, this alcohol goes through the capillary tube, and when it comes to the correct place, we can read it. Now this thermometer is calibrated in degrees Celsius. Look at this one. Degrees Celsius, you all can see it clearly, right? Okay. And some other thermometers are calibrated in degrees Fahrenheit. Okay, children? So this is a bulb thermometer. The bulb is filled with colored alcohol. Look at this thermometer, children. This is also a similar type of thermometer, a bulb thermometer, but this bulb is filled with mercury. Mercury is a liquid metal. You all can see it's silver in color. Because of the silver color, when we immerse this in a liquid, when this mercury level goes through the capillary tube, we can observe it very clearly. Even this thermometer is also calibrated in degrees Celsius. Right, children? Okay. Now the next thermometer is known as the clinical thermometer or medical thermometer. So these type of thermometers are used to measure the body temperature. Now you all can see this is much shorter than the previous two thermometers. What is the reason, children? Because the body temperature ranges within a short range. Therefore, we don't need to use a long thermometers like this. Okay, children. Now, this is a mercury thermometer. You all can see if you observe carefully. This is the bulb. You can see the capillary tube. You all can see here, this thermometer is calibrated in both degrees Celsius and Fahrenheit. Right, children? And can you all see when you go through the readings, here this 37 is marked in red color. That is the normal body temperature or body temperature of a healthy human. Okay, children? This is the normal body temperature, 37 degrees Celsius. Okay, children? Right. Now, this thermometer is the digital thermometer. Now, these digital thermometers, they have special sensors in this bulb-like part to identify the body temperature. So, with this type of button, you can switch it on, right? And you can switch it off with the same button. Right, children? So, other than using these bulb thermometers, using digital thermometers, we can read the temperatures very easily, and there are different types of digital thermometers as well. So I hope you got an idea about different types of thermometers. Okay, children. So you observe different types of thermometers that we can use. Okay, I hope this part is clear now. We'll move on to the next. We have another activity to do. So far we discussed about expansion of solids and expansion of liquids. Now we are going to learn about expansion of gases. So here we have an activity to do. Let's learn about the expansion of gases, right? So what are the things we need? We need an empty glass bottle, we need a coin, and we need a hot water beaker. Okay, let's label. Empty glass bottle, we need a coin and a hot water basin or hot water beaker. Right, now I'm going to explain the activity. You all can do this activity at home very easily. Okay, let's see how to do that. Right, method. We have the diagram. Take a bottle without a lid and apply some water to the mouth of the bottle, right? And then keep the coin on the mouth of the bottle and close the mouth. What we have to do is we have to take the empty glass bottle. First of all, we label this. Right. This is the coin. This is the empty glass bottle. This is hot water and this is the beaker. Coin, empty glass bottle, beaker, and here hot water. Okay, take a bottle without a lid and apply some water to the mouth of the bottle, right? Then keep the coin on the mouth of the bottle and close the mouth. Now, before we place the coin, we have to apply some water to the mouth of the bottle. So, by doing this, when we place the coin, what will happen? It will nicely cover the bottle by sealing it. Okay? Place the bottle in the beaker with hot water, right? And observe what happens to the coin. Now, this is going to be a very interesting activity. We'll go to the lab to see this. Right, children. Now we are going to study the expansion of gases. So, I already explained you all what we need to do this activity. Here I have an empty bottle, a 2 rupee coin, and I have a water beaker with hot water. Okay. So, first of all, I am going to place this coin on this bottle. Before that, I have to apply some water. Right here on the mouth of the bottle. So we can, when we place this 2 rupee coin, it seals very well. Okay, children? Now I have to immerse this bottle. Carefully observe what happens to the coin when I immerse this bottle in the hot water beaker, okay? You can see the coin is moving. Right, children? The coil is moving up and down. So why does this happen, children? Even though the bottle looks empty, we all know that the bottle is filled with air. Right, children? So what happens when I close this bottle with the coin? The air cannot go out. Right, children? And when I immerse this bottle with air in this hot water beaker, what happens? The air inside gets heated up and the volume of the air increases, and this is known as expansion. When the volume of the air increases, it needs to occupy more and more space. But there's no more space inside the bottle. The only option is the air has to escape through the mouth of the bottle. Right? So when the air is escaping through the mouth of the bottle, it gives a little push towards the coin, and that's why the coin moves. Right, children? So it's very clear that when we provide heat, air expands or the volume of the air increases, and this is known as the expansion of air. So this very same activity we can do in different other ways. I am going to show you 2 more ways of doing the same activity. Okay, children? Right. Now look at this bottle, children. Now this bottle is empty. Now we all know that even though the bottle looks empty, it's filled with air. And you all can see I have connected a balloon to the mouth of the bottle. Right, children? Now I'm going to immerse this bottle in this hot water beaker. Observe what happens carefully. Look what happens to the balloon. Look what happens to the balloon, children. The balloon slowly inflates. It happens very slowly. Right, children? Yeah. Right. The balloon slowly inflates. What is the reason, children? When I immerse this empty bottle, empty means already air is filled inside this bottle. So the air inside the bottle expands, which means the volume increases. When the volume of the air increases, it doesn't have anywhere else to go other than going out of the mouth of the bottle. Right? It needs to occupy more space. So in that case, when it goes out of the bottle, what happens? As the mouth of the bottle is covered with a balloon, that increased volume of air gets filled inside the balloon, making the balloon inflated. Right, children? So this is the reason the balloon gets inflated. Okay. I'm going to show you the third activity now. Now you all can see this test tube is empty. Even though it looks like empty, it is filled with air. And I have fixed this rubber stopper with that empty pen tube. And you all can see this colored drop of water is trapped inside this pen tube. Okay, children? Now, this time I am not going to immerse this tube in water. Instead, I am going to rub it a little with my hands. Look what happens to the drop of water. So when I hold the test tube tightly with my hands, look what happens. You all can see the drop of water goes up. Okay, children, you can see clearly the drop of water goes up. right? Right, children. Why does this happen, children? When I hold this test tube with my hands, my body heat transfers into the test tube. And then the air inside the test tube gets heated up and its volume increases, which means it expands. Okay, children? So when this air expands, what happens, children? That increased amount of volume goes through this empty pen tube, right? As the air goes through the empty pen tube, along with the air, this water bubble also goes up. Okay, children, now this is another example that we can show that when we provide heat, air expands, so the volume of the air increases. So I hope after doing these three activities, you understood what expansion of air or expansion of gases means. Right, children? So I hope you observed all three activities I showed you all. Okay, so under the same activity, even though we wrote only one activity here, I showed you two similar activities to this activity, right? So what happened? We took this empty glass bottle and we placed this coin on the mouth of this empty glass bottle, and then what we did? We immersed this empty glass bottle in this hot water beaker. What did you observe? You could clearly see that the coin goes up and down time to time. Okay, the coin goes up and down. So I explained you all what happens. Even though the bottle looks like it's empty, even though we can't see, you all know that the bottle is filled with air. Right, children? So you all know that air is a mixture of gases. Right? So the bottle is filled with air. When we immerse this bottle in this hot water, what happens? That air inside the bottle absorbs heat, and then what happens? The volume increases, and this is known as the expansion of gases. Now volume increases means as air spreads throughout the entire space, when the volume increases, it doesn't have enough space inside the bottle to move. Thereby, by pushing the coin upwards, this air goes out. Right, children? So because of that, we can see the coin moves up and down. Understand, children? So after doing this activity, it's very clear that air expands. Air's volume increases when it absorbs heat. Okay, children? Do you remember what are the other two activities we did? We'll draw a small diagram here to show that one. So we took another glass bottle, and then what we did? We fixed a balloon to its mouth. And then we immersed this empty glass bottle with a balloon in a hot water beaker like this. So what did you all observe? When we immerse this empty bottle with a balloon fixed like this in this hot water beaker, what did you all observe? You could see clearly the balloon inflates. So again, what happens? Even though the bottle looks empty, air is filled inside the bottle. So when we immerse the bottle in hot water, it absorbs heat, and therefore the air inside the bottle expands, which means the volume increases, right? So then the increased volume goes out of the bottle and it's collected inside the balloon. So that when air gets filled inside the balloon, what happens? The balloon inflates. Okay, children? Right. Do you remember the third activity we did to prove that air expands when heat is provided? Right. There what we did was, we connected an empty pen tube to an empty test tube like this. So this is the empty pen tube. This is the empty test tube, and we connected it using a rubber cork. And before we start this activity, what we did was, we trapped a drop of colored water inside the empty pen tube. I'll show it in a different color. A drop of colored water inside the empty pen tube. So then what did we do? We held this empty test tube with our hands tightly. Then you could observe that this colored drop of water moves up. So why does this happen, children? When we hold this empty test tube with our hands, the air inside this test tube absorbs the heat of our body. right? Because of our body heat, it's absorbed by this air inside the test tube. The air inside the test tube expands. Right, children? Expansion means increase in volume. Right? The volume of the air increases, and then what happens? The increased air goes up through this empty pen tube, and because of the increased level of air, it pushes this drop of water up. Okay, children. So after doing all these three activities, it's very clear that air expands when heat is provided. Okay? Let's write observation. Right. We are going to write the observation only for this one, okay? Right. When bottle with the coin on its mouth is immersed in the hot water beaker, the coin moves up and down. Right? When the bottle with the coin on its mouth is immersed in the hot water beaker, the coin moves up and down. Right? What is the conclusion? We'll write the conclusion and the reason for that as well so that you can understand it better. Conclusion. When heat is supplied, air, or we can write gases also. Air expands. The volume of air increases. Okay, we'll write actually what happens here. When the bottle is immersed in hot water, the air in the bottle absorbs heat and its volume increases. Its volume increases. This increased volume of air goes out of the bottle by pushing the coin up. This is the conclusion, right? This happens because of the volume of the air increases, right? So actually what happens here? So when heat is supplied, air or gas expands or volume of air increases, okay? So how does that happen? When the bottle is immersed in hot water, the air in the bottle absorbs heat and its volume. And we have written this twice. Let's erase this. Right, absorbs heat and its volume increases. This increased volume of air goes out of the bottle by pushing the coin up. This is the reason for this observation. Okay, children? So I hope you understood this part clearly. We'll move on to the next. Right. Look at this. It's a kind of question. Blow a balloon and tie the mouth of it tightly. Then keep it in a place where sunlight falls. See what will happen to the balloon. Explain about your observation. Now, this activity also you all can do at home very easily. Some of you must have observed these type of situations, right? Sometimes in functions when there are, most of the time balloons are used. So most of the time if the functions are held during daytime, what will happen? You must have seen the balloons burst time to time. Why does this happen, children? So what happens? What do you have to do here? You have to blow a balloon, tie its mouth tightly, and you have to keep it in a place where sunlight falls. What happens, children? When sunlight falls onto this, what happens? This gets heated up. So even though we can't say inside the balloon there is air. So what happens? Because of the sun's heat, this air inside the balloon gets heated up. And what do you think will happen? Yes, the air will expand. Expand means the volume increases. Volume increases, and because the balloon is made with rubber, the balloon membrane also can expand. Right? The balloon membrane also can increase its volume. But what will happen at one point? There will be no enough space for this entire amount of expanded air inside the balloon. That time what will happen? The balloon will burst. Right, children? So you all can do this activity very easily. We'll write this down. See what will happen to the balloon. Explain about your observation. Right? Let's write. Due to the sun's heat, the air in the balloon expands, which means the volume increases. When the air expands more and more, due to the lack of space, the balloon will burst. Okay? Due to the sun's heat, the air in the balloon expands. When the air expands more and more, due to the lack of space, why does that happen? When it keeps on expanding, more pressure is created on the balloon wall or this balloon membrane, right? When it is too much of air pressure inside the balloon, what will happen? It will stretch and at one point it will burst, right? So due to the lack of space, the balloon will burst. Okay? We'll move on to the next. We have an assignment to do. Search the instances where the expansion takes place. List out the instances in the given table. Now you can look into these type of examples by reading books, and you can search the internet. Okay? So how to do this? In this column we have to write the object, and in this column you have to write how did you identify that it is expanded. So what are the instances? Now some of these instances we already discussed, right? Object, we can start it off with a thermometer, right? Let's write the first one. Thermometer. First object. Thermometer, right? So how to identify that the expansion has taken place, children? You all know when we immerse the thermometer in a liquid or when we measure the temperature of any object using the thermometer, you have to immerse the bulb in that particular substance, right? Then what happens? So the liquid level inside the thermometer, the capillary tube, increases. Right? So we know that if the liquid level rises or goes up through the capillary tube, we know that expansion has taken place. Right? Why does this happen again, children? Let's say that when we immerse the bulb of the thermometer in hot water, because of the heat of the water, the liquid present in the thermometer bulb expands. Its volume increases. Right? So according to the increase of this volume, that liquid level inside the small capillary tube in the thermometer goes up, right? So when that happens, we know that this happens because of expansion of liquids, right? Let's write, how did you identify that it is expanded? The liquid level in the capillary tube goes up, increases. This is the first one. What is the second object, children? Do you remember in the beginning of this expansion topic we discussed about rails of a railway? We'll write that one as well. Rails of a railway. Right. Rails of a railway. So, how can you identify whether the expansion has taken place? Now, do you remember I already explained y'all what happens when we consider two rails of a railway? Normally, there's a gap between the two rails. Right? This is the gap between the two rails. Right? There's a gap. Okay? So, during the daytime, what happens? Because of the environmental temperature, these rails are made of metals, right? The rails get heated up and therefore they expand. The length increases. So when the length increases, what happens? Now this is the first rail and this is the second rail. When the first rail's length increases, it happens like this. In the second rails also, when the length increases, there's enough space for the increase of length. Right, children? Because of the presence of this gap. So what happens? We can identify whether they have expanded or not by looking at the gap. If the gap is big, which means the expansion is less, so expansion has not taken place. But if the gap is closed, we know that these two rails are expanded. Its lengths have increased. Okay, children, when the lengths increase, the gap closes. To facilitate this expansion of these rails, we have to leave this little gap. Okay? So, rails of a railway, how did you identify that it is expanded? The gap between the two rails closes up when they expand, right? Let's write rails of a railway. The gap between two rails closes up. So if it is closed up, we know that expansion has taken place, okay? Right. What are the other instances, children? I'll write one more instance. What are the other instances? Now you must have observed how these electrical cables are fixed, right? So electric poles in the roadside, they present like this, right? So this is the road, they are fixed like this. So you all must have seen these cables present like this, right? From one pole to the other pole. But have you ever observed when there is strong sunlight, what happens to these cables, children? Have you ever seen sometimes these cables without being stretched like this, they sometimes hang, right? You must have seen sometimes these type of electrical cables are hanging like this, right, children? What is the reason? Because during the daytime, because of absorption of heat in the environment, these electric cables, they expand. Because of the expansion, their length increased, right? So because of the length increased, we can see they are hanging like this. Okay? So again, during the night time, what happens? The environmental temperature is lower than during the daytime. Therefore, they contract. We explained this as well. Right, children? So due to when we provide heat to an object, its size increases and this is known as expansion. Right? When the heated object releases its heat, what will happen? Its size reduces and this is known as contraction. Okay, children? Right, let's write third object. Cables. What will happen? They hang loosely during daytime. Okay? They hang loosely during daytime. Right? Thermometer, how did you identify that it is expanded? The liquid level inside the capillary tube goes up. Right? Rails of a railway, the gap between two rails closes up. Okay? Electrical cables, they hang loosely during daytime. Right? So you can write other examples as well. Observe your environment. You can even add that sometimes in order to open a metal lid that is tightly fixed to a bottle, what can we do? We can pour some hot water, right? So that also you can write as an example. So we know that it is expanded when we can open it easily, right? We know that it is expanded, okay? So those type of instances you all can write as examples. You can look at your environment and you can find more examples to do this activity. Right, children? We have completed this chapter. So in the previous chapter, we learn about expansion of solids, and this chapter we learn about expansion of liquids and gases. So we are going to learn more about the other effects of heat in the next chapters.